Hello everyone, this is Visalakshi. I am going to do some lessons in mathematics for grade 10 CBSE students. I hope this will help you to secure good marks in your final exam. I am going to teach you chapter wise. So in this class, I am going to first start with the first chapter, real numbers. So let's have a quick review of all the important concepts and formulas in this real numbers. Then I am going to do some MCQs in this relevant topic. Okay. Now let's get started. Yes. So this is first chapter, real numbers. First, let's start with the important lemma called Euclid's division lemma. Okay. The lemma states that given positive integers a and b, there exists unique integers q and r satisfying a equal to bq plus r, where r lies between 0 and b. Okay. So here we call this a as dividend, b as divisor, and q is the quotient and r is the remainder. So we can write dividend equal to divisor into quotient plus remainder. So if r is equal to 0, in Euclid's lemma, if r is equal to 0, if there is no remainder, then b would be the HCF of a and b. Then we see one by one what are natural numbers. Natural numbers or counting numbers starts from 1, 2, 3, etc. They are called natural numbers. And what are whole numbers? All counting numbers or natural numbers along with 0 are called whole numbers. What are integers? All natural numbers, negative of natural numbers and 0 together are called integers. That is, integers have both positive values, negative values, including 0. And what is algorithm? An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. And lemma. Lemma is a proven statement used for proving another statement. So, what is the application of this Euclid's division algorithm? Okay. So, this is a technique to compute highest common factor of two given positive integers. Okay. So, we know highest common factor is also called greatest common divisor of any two positive integers a and b. We can find what is the highest common factor. So this Euclid's division algorithm is used to find the HCF of two positive integers a and b. So as we proceed, you can see these are the steps we need to follow to find the highest common factor of two positive integers. Okay. Let us say the two integers are c and d. C should be greater than D. So the steps need to be followed are, first in step 1, apply Euclid's division lemma to C and D. So to find the whole number Q and R such that C equal to DQ plus R, R obviously lies between 0 and D. So if R is equal to 0, D is the HCF of C and D. If R is not equal to 0, we have to apply the division lemma to D and R again. So we have to continue the process till the remainder is 0. So the divisor at this stage will be required HCF. Okay, so this algorithm works because HCF of CD is equal to HCF of DR. So here this is the symbol, HCF of CD denotes the HCF of CD. This is the symbol we are going to notation to represent HCF of any two positive integers. Then we discuss the fundamental theorem of arithmetic. What is the fundamental theorem? States every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Okay, every composite number can be uniquely expressed as the product of prime factors. Okay, so the prime factorization of a natural number is unique except for the orders. HCF, as I told you, is also called, HCF is the highest common factor, also called GCD, greatest common factor. LCM of two numbers is the least common divisor. So properties of HCF and LCM of two positive integers A and B is given by, so we can write the HCF of any two integers into LCM of any two integers is equal to product of the two integers. Okay, so using this, if we can find, if HCF is given, HCF of any two numbers is given, and if we need to find the LCM, then finding the product and bringing the HCF to the denominator, we will be easily find what is the LCM. Similarly, if LCM is given for any two integers, we need to find the HCF, and we can easily find by using this relationship. So the relationship is HCF of any two integers into LCM of any two integers is equal to product of the integers. Next, what is prime factorization method? Okay, so in this method also we can easily find the HCF and LCM. Okay, so HCF, to find HCF we can use Euclid's division algorithm, or by prime factorization method also we can find HCF. Okay, so HCF of AB is equal to product of the smallest power of each common prime factor in the numbers. Okay, so this I will explain you while doing some problems. And LCM is also, we can find LCM also by using prime factorization method. LCM is the product of the greatest power of each prime factor involved in the numbers. Okay, now let's move on to rational numbers. What are rational numbers? So the number in the form of P by Q, where P and Q are integers and Q not equal to 0, are called rational numbers. For example, 2 by 3, 3 by 5. So P and Q must be an integer and Q should not be equal to 0. So every rational number can be expressed in decimal form, and the decimal form will be either terminating or non-terminating, repeating. Here you can see in this example 5 by 2, you can convert this 5 by 2 rational number into the decimal form 2.5, which is a terminating one. So this we call as a terminating decimal. Okay, and 2 by 3, when you convert this 2 by 3, this rational number into a decimal form, this you can write it as 0.666. Here the 6 is repeating, so you can write it as 0.6 bar. So here as the 6 is repeating, not terminating, so this is called a non-terminating repeating decimal form. Next, I tell you what are rational, irrational numbers. We have just seen what are rational numbers. A number in the form of P by Q, where P and Q are integers and Q should not be equal to 0. This is these are called rational numbers. And irrational numbers, the numbers which are not rationals are called irrational. Example, root 2, root 3, root 5, etc. These are called irrational numbers. So let P be a prime number. These are some statements. If P, let P be a prime number, if P divides A square, then P divides A, where A is a positive integer. So if p is a positive integer which is not a perfect square, then root m is an irrational. So the number which is not a perfect square, root 2, root 5, root 6, these are called irrational numbers. So if p is a prime number, we know what are prime numbers. A number which is divisible by itself and 1 are called prime numbers. So if p is a prime number, then root p is also an irrational. Okay, I hope this is clear. What are irrational numbers? Now let's move on. Rational numbers and their decimal expansion. So this is a theorem. It states that let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form p by q, where p and q are co-prime and the prime factorization of q is of the form 2 power n into 5 power m, where n and m are non-negative integers. This is a theorem. Using this theorem, we can convert the given decimal expansion into rational form by using if q is of the form 2 power n 5 power m, then we can easily convert this decimal expansion into rational number or vice versa. Okay. Yeah. So let x is equal to p by q is a rational number given such that prime factorization of q is of the form 2 power n into 5 power m, where n and m are non-negative integers. Then x has a decimal expansion which terminates. So these two theorems are vice versa. So if one is given, we can tell whether it is a decimal expansion terminates or not by checking this q. If this q, the denominator is of the form 2 power n and 5 power n, then we can tell it is a terminating one or non-terminating one. And the next theorem, if x is equal to p by q be a rational number such that the prime factorization of q is not of the form 2 power n and 5 power n, then the decimal expansion is non-terminating, repeating. Okay. So some examples are given. The decimal form of irrational numbers is non-terminating and non-repeating. So those decimals which are non-terminating and non-repeating will be irrational numbers. So you can see 0.20, 2002, 000. So this decimal form is keep on growing, is a non-terminating and non-repeating decimal. So it is irrational. So if you want to find whether the given decimal is non-terminating or terminating one, so here you can convert into the decimal form and check. So this I will explain while doing problems. Now let's move on. Now let's do some MCQs in chapter 1. What is the first question? A rational number between 3 by 5 and 5 by 4 by 5. A rational number between 3 by 5 and 4 by 5 is. The options are given: A 7 by 5, B 7 by 10, C 3 by 10 and D 4 by 10. So here you can observe in both the rational numbers the denominator is 5. So you can convert the denominator, because here in these three options the denominator is 10. So you can convert this 5 into 10 and you can check with the given options. See, I am converting this 3 by 5 by multiplying and dividing this 3 by 5, numerator and denominator by 2, I get this as 6 by 10, and this 4 by 5 multiplying and dividing by 2, I can convert this into 8 by 10. So I made the denominator into 10. Now I am comparing with the given options. The options are 7 by 10, 3 by 10, 4 by 10. So here the first rational number is 6 by 10 and the second one is 8 by 10. Obviously 7 by 10 is the rational number which lies between these two, 6 by 10 and 8 by 10. 3 by 10 and 4 by 10 are smaller than these 6 by 10, and 7 by 5 is not the option. So 7 by 10 is the right option. So for the first problem, the answer is 7 by 10. So we got the rational number which lies between 3 by 5 and 4 by 5. Next, we go to the next one, the rational number between 1 by 2 1 by 2 and 3 by 4 is. Now similarly I am going to do this also. Here what are the given options? First let's have a look. What are the given options? Please just wait, I can't move the screen. Yeah, the second question is a rational number between 1 by 2 and 3 by 4 is. Here as you can see, the first option is 2 by 5, the second one is 5 by 8, 4 by 3 and 1 by 4. So you can easily convert the given rational numbers, the denominator into 8, and we can compare with the given options. So let's do it. Here 1 by 2 can be easily converted into by multiplying and dividing by 4. You can convert this into 4 by 8, and 3 by 4 also multiplying and dividing by 2. You can convert this into 6 by 8. So here you can check with the given options. 2 by 5, 5 by 8, 4 by 3, 1 by 4. 4 by 8 and 6 by 8 are the rational numbers. So here 5 by 8 lies between 4 by 8 and 6 by 8. So the option is B. Yeah. Now let's go to the next problem. Which one of the following is not a rational number? So a rational number is not a rational number, means it is irrational. Okay. So here we can see A option root 2, 0, root 5 and root minus 16. These are the given options. What is asked is not a rational number. A number which is not a rational number is called an irrational number. So from the given options, what is the which is the irrational one? This one, root 2. The option is root 2. The other numbers you can express in the form of p by q. 0 can be expressed in the form of 0 by 1. Okay, and root 4 is nothing but 2. So 2 by 1, you can express root 4 as 2 by 1 in the p by q form. And root of minus 16 is nothing but 4i. So this is an imaginary one. Okay, so what is the question? Not a rational number means it is an irrational number. Root 2 is obviously an irrational number. Okay. Now, what is the fourth question? Which one of the following is an irrational number. Irrational number means square root of some value. Okay, so here root 4 is 2 and root 100 is 10 and root of minus root of 0.64 is minus 0.8. Okay, so these are not irrational. So which is the only one an irrational number? 3 root 8. 3 root 8. So this is the option. Option B is the correct one for fourth question. Then the fifth one, 3 into 3 by 8 in decimal form. So how we can write this fraction 3 into 3 by 8 into the decimal form? Now let's solve. Yeah, so you can write 3 by 8. So multiplying 8 3s are 24, 24 plus 3 is 27, 27 by 8. So divide 27 by 8. So this is 8 3 times is 24 and the remainder is 3. So this is smaller than 8, so put a decimal point and put 0. So this is again 3 times 24 and here the remainder is 6 and put 0 again and this is 7 times 56 again and the remainder is 4, again 0, 8 times 5 is 40. So here we get the remainder as 0. So 3.375 is the answer when we convert this decimal form 3 by 8 in this way, this 27 by 8 and dividing, we get the quotient as 3.375. Option B is the right one. Yes. Now let's move to the next one. The sixth problem, 5 by 6 in decimal form is 5 by 6. So you have to divide 5 by 6. Okay, 5 is smaller than 6, so put here decimal point. Okay, and 0. So this is 8 times 48. 6 times 8 is 48. Again here you get 2, put 0 and this is 3 times 18. So again 2, 0 and again 3 times. So this grows like the same. Okay, so the answer is 0.83. so here 3 is repeating again and again, so you can express this as 0.83. as this 3 is repeating, you can put a bar over it. Okay, so 0.83 is the answer to write this fraction 5 by 6 in decimal form. The option is A. Yeah. Now let's go to the next problem. Decimal representation of rational number 8 by 27. Okay, so decimal expansion, divide 8 by 27. So you can see 8 is smaller than 27, put a decimal point and put 0. So this is 2 times it is 54 and here 6 and this is 7 minus 5 is 2. Okay, then again 0. So you get 9 times this is 24 and subtracting this, 10 minus 3 is 7 and 5 minus 4 is 1. Okay, and again putting 0. I think it is 6 times 42, 4, 12, it is 16. Okay, and again you are getting the remainder as 8. Okay. So again this continues. So what? Again we put 0. So this goes 2 times, and again we get the remainder as the same. Okay. So this will repeat. 296 will keep on repeating. So this is non-terminating and repeating, non-terminating and repeating. So you can express 8 by 27 in the form 0.296. As this 296 is keep on repeating, you can put a bar over it. So this is the answer, 0.296. The option is A. Next, we solve this 8th one, 0.666 in PQ form. Okay. So in PQ form, how to write this? So you check with everything, and the option A is 6 by 99, 2 by 3, 3 by 5, 1 by 66. Obviously this 3 by 5 is the answer. You can check once. 3 by 5, we know 3 times 5 times 6 is 30. Okay. So 3 by 5, divide 3 by 5, 3 is lesser than 5, put a decimal point. So this is 0. So we have to write this decimal form into fraction. Decimal form into fraction. So here (0.666). Okay, so this is 0.6 bar. Okay, so first what we do, we multiply this 0.666 by 10. Let it be n. Okay, n is equal to this. So multiply both sides by 10. So we get 10 times n is equal to 6.66. Okay. Now let it be equation 1 and this be equation 2. Okay. Subtracting 2 from 1, so we get 10n minus n, okay, which is 9n. Okay, 9n is equal to 6.666 minus 0.666, it goes on. So this is just, when you subtract this, you get 6.000. Okay, this is 9 times n. So n is equal to 6 by 9. Cancelling this by 3 table, you get 2 by 3. Okay, so 2 by 3 is the rational form of the given decimal value, 0.666. Okay, so let me explain it again. 0.666 is nothing but 0.6 bar. Okay, 6 is repeating. So let us consider the given decimal value as n, make it as equation 1, multiply both the sides by 10. So we get 10n equal to, so when you multiply this decimal form by 10, you get this decimal point will move to right side. So 6.666. Now subtract equation 2 from 1, 10n minus n is 9n, and subtracting this 6.666 and 0.666, you get 6.000. Okay, so that is just 6. So we need to find the rational form, that is the fraction. Okay, so n is equal to 6 by 9, and you can simplify this into 2 by 3. So 2 by 3 is the right answer for the 8th. I hope this is clear. Now let's move to the next one, the 9th question. The value of root 5 plus root 2 into root 5 minus root 2 is. Okay, so the given expression is of the form a plus b into a minus b. A plus b into a minus b. So, we know a plus b into a minus b is equal to a square minus b square. Okay. So, writing this expression in this way, root 5 into root 5. Root 5 whole square is just 5. Okay. So, 5 and minus root 2 whole square is 2. What is 5 minus 2? 3. Okay. The answer is 3. Now, the last question. 0.36 in P by Q form. Okay. 0.36. So, as we did the 8th one, this is also very simple. Let's do it. 0.36. So, here this 36 is keep on repeating. It is recurring. 0.36, 36. So, 2 decimal values are repeating. Okay. So, we need to let us consider this 0.36 as n. Now, multiply this equation 1 by 100. So, 100 times n, because here 2 decimal values are repeating. So, I am multiplying both sides of this equation by 100. So, I get 36.3636. This will keep on going. Okay. Yes. Now, let it be equation 2. So, if we subtract equation 2 from 1, so that is 100n minus n is 99. 99n equal to 36.000. So, n is equal to 36 by 99, and the given options 36 by 99, we got 36 by 99. The options are 6 by 99, 2 by 99, 3 by 5, none of this. 36 by 99, we got 36 by 99, but here it is just 6 by 99, and we can't write 36 by 99. 36 by 99, we can simplify this into 2 by 3 or something. Okay. So, the answer is none of this. Yeah, now let's solve one more MCQ worksheet in the same chapter. This is worksheet 2, chapter 1. Yeah. The first question is root 5 minus 3 minus 2 is, the options are a rational number, a natural number, equal to 0, and irrational number. Okay. So, the number which is not of the form P by Q is an irrational number. So, obviously, the answer is an irrational number. The sum or difference, we know, you have learnt the sum or difference of any two non-zero rational number is an irrational number. The answer is an irrational number. Now let's solve the second one. Let x is equal to 7 by 20 into 25 be a rational number. Then x has decimal expansion which terminates, what are the options? After 4 places of decimal, after 3 places of decimal, after 2 places of decimal, after 5 places of decimal. So, we have to check the given rational. So, after which decimal places it is terminating. So, to solve this, what we do, we have to convert the denominator into 2 power n into 5 power m form. Okay, now let's do it. Here the given option, see, the given number, rational number is 7 by 20 into 25. Now I am converting the 20. I am writing the factor of 20, which is 5 times 4. So you can write it in the, so when you factorize this, you get 5 into 2 into 2, the prime factors of 20. And what are the prime factors of 25? 5 times 5. Okay, so here this is 7 by 2 square into 5 cube. Okay, so here 5 is repeating 3 times. So I am multiplying the numerator and denominator by 2. Okay, so I am converting that into 7 times 2. Okay, let it be, it is 14. Okay, and here this will become, the denominator will become 2 cube into 5 cube. So which is nothing but 14 by 10 cube. Okay, so this is 10 cube, that is 1000. So when you divide 14 by 1000, you have to write it in this way, 0.014. Okay, so this rational number will terminate after 3 decimal places, 0.014. So it will be terminated after 3 places of decimal. Okay, so what is the option? B. After 3 places of decimal, it will terminate. So option B is the right choice. Now the third one, the decimal expansion of 63 by 72 into 175. So as we did the second problem, this is similar to that. So we have to convert the denominator into prime factors and we have to write it in the form of 2 power n into 5 power m. Then we can easily say whether it is terminating, repeating or not. Okay, so if the denominator is not of the form 2 power n and 5 power m, then it is non-terminating. So now let's try to convert it in the form. So what is given? 63 by 72. So what are the prime factors of 72? It is 8 times 9. 8 times 9. So 8 is 2 cube and 9. Okay, let it be, and 175. So what are the prime factors of 175? It is 5 times 175. Let's do 5 times 3 times and 5. Okay, and 5 times 7. Okay, so 5 into 5 into 7. Okay, yeah. Now let's try to cancel the numerator and denominator. 7 times 9 is 63 and this 9 and 9 will get cancelled. So in the numerator we have just 1 divided by 2 cube into 5 square. So multiply the numerator and denominator by 5 so that I get the denominator as 2 cube into 5 cube. Okay, so this becomes 5 by 10 cube. So this is 0.005. Okay, so it is terminating, right? It is terminating after 3 places of decimal. Okay, so here the given options are terminating, non-terminating, non-terminating and repeating, and irrational number. Okay, obviously this is not an irrational number, this is a rational number and it is terminating. Okay. Yes. Now if HCF and LCM of two numbers are 4 and 9696, then the product of two numbers is, okay, the options are given. So we have seen the relationship between HCF, LCM. Okay, so what is the relationship? HCF of any two numbers, HCF of A and B multiplied by LCM of A and B is equal to product of the numbers. We know this. Here what is given? HCF of the two numbers are 4 and LCM is 9696. Then we can easily find the product of two numbers using the above relationship Okay, so if we want the product of these two numbers, just multiply the HCF and LCM. What is the HCF? 4, and what is the LCM? 9696. So here we get 2 times 8 and 3 times 7, 3 times 36, and again this is 38. Okay, so when you multiply the HCF and the LCM of any two numbers, we get the product of those two numbers. Okay, so here the product of the numbers is 38784. Okay, the option is this one, option C. Okay, and the fifth question is 2 plus root 3 plus root 5 is. Okay, so this is obviously an irrational number. The options are a rational number, a natural number, a integer number is an irrational number. Okay, the sum or difference of any two irrational number, non-zero irrational number, is an irrational number. Okay, next, the sixth question. If 9 by 7 whole cube plus 49 by 81 whole power 2x minus 6, 2x minus 6 equal to 7 by 9 whole to the power 9, the value of x is. Okay, so here what is the value of x we need to find. Okay, now so the LHS and RHS, in the RHS we have 7 by 9 whole to the power 9. So we have to convert the LHS into the same form so that we can compare the power. Okay, so this 9 by 7 whole cube, okay, keep as it is, and 49 by 81 is nothing but 49 is 7 square and 81 is 9 square. So this is 7 by 9 whole square. Already here we have 2x minus 6, right? So the RHS, this is LHS. LHS is 9 by 7 whole cube, and this will get multiplied by 2, this power. So this becomes 4x minus 12. Okay, and when you write this 9 by 7 whole cube, when you take the inverse, this becomes 7 by 9 whole to the power minus 3, and keep this 7 by 9 whole to the power 4x minus 12 as it is. Now adding the powers, we get 4x minus 12 minus 3, that is 7 by 9, 7 by 9, 7 by, here I write 7 by 9 whole to the power 4x minus 15, right? So you can, yeah, 7 by 9 whole to the power 4x minus 12 minus 3 is minus 15. The RHS is 7 by 9 whole to the power 9. Okay, so equating both sides, the powers, 4x minus 15 equal to 9. 15 will go to the right side, so you get 4x equal to 15 plus 9. 15 plus 9 is 24, right? So we need to find what is x. So x is obviously 24 by 4. So 4 times 6 is 24. X is equal to 6. Yes, x is equal to 6. Option D. Okay, and what is the seventh one? The number 0.211, 211, 21111. It's keep on increasing. Okay, you can see the decimal form is keep on increasing. So what is being asked? It is terminating decimal, non-terminating decimal, non-terminating and non-repeating decimal, none of these. Okay, so this is non-terminating and as well as this is non-repeating. See, this is not repeating. So here we have 2 ones and 3 ones and 4 ones. It keeps on increasing. So it is not repeating. Okay, so it is a non-terminating and non-repeating decimal. Okay, so the option is C. Yeah. Now let's solve 3 more problems. If m to the power n is equal to 32, where m and n are positive integers, then the value of n to the power m into n is. Okay, so how to find the value of n to the power m into n. From this you can write m to the power n. 32 is in the form of m to the power n. Okay, so this is very simple. We know 2 to the power 5 is 32. Okay, so what is m here? M is 2 and n is 5. Okay, and what we have to find? We have to find n to the power m into n. We have to find n to the power m into n, right? Let's check. Yeah, we have to find n to the power m into n. What is n? N is 5, m is 2. So 5 to the power 5 into 2, right? 5 into 2 is 10. Okay, 5 power 10 is the answer. Option C. The number 0.57 whole bar in the P by Q form. Okay, so I have solved problem of the same one in the previous MCQ worksheet. Yeah, again let's solve. Okay, the number 0.57 whole bar. Okay, so the number is 0.575757. Okay, these two decimal values is repeating. Okay, so let it be n. So as this 57 two decimal values are repeating, multiply this equation, let it be equation 1 multiply by 100. Okay, so 100n is equal to 57.575757. It will keep on going. Okay, now let it be equation 2. Okay, now let's subtract 2 from 1. We get 100 minus n is 99. 99n is equal to 57.5757 and 0.5757. So we get 57. Okay, so n is equal to 57 by 99. Okay, 57 by 99 is the PQ form of the given decimal expansion 0.57 bar. Okay, now let's solve the next one. Next one is the number 0.57 bar in the PQ form. Okay, so in the ninth one it is 0.57 bar. 57, the two decimal values are repeating. Here only 7 is repeating, not 5. Okay, yeah, now let's do it. Let it be n. Okay, so n is equal to 0.5777. Okay, now we know only one decimal value is repeating. So when one decimal value is repeating, then we multiply it by 10, right? 10. So we get 10n is equal to 5.7777. Okay, fine. Now, so when you subtract, when you consider this as equation 2 and subtract, we won't get the result. Okay, because here n is 0.577, 10 times n is 5.777. Okay, so now let's again multiply the equation 1 by 100. Okay, so you get 100 times n is equal to, when you multiply equation 1, the right side becomes 57.777. Okay, now you consider this as another equation, let it be 2 and this be 3. Now you have to subtract 3 from 2. Okay, so that is 100n minus 10n equal to, here it is 57.777 and this is 5.777. So when you subtract, you get it as, here this is 0, right? So 52.000. Okay, on the left side 100n minus 10n is 90n, right, 90n. So what is n? N is equal to 52 by 90. Okay, got it? 52 by 90. So you can simplify this further by dividing both the numerator and denominator by 2. Okay, so when you divide it by 2, you get this is 26 times, right? 26 by 45. So this is the right option. Divide the numerator and denominator by 2, you get 26 by 45. This is the right answer for that problem. Okay, and any one of the numbers a plus 2, a plus 4 is a multiple of, okay, multiple of 2, 3, 5, 7. So this is the multiple of what? You can apply here, put a equal to 2. So when you put a equal to 2, what you get? 2, 4, 6. Okay, so the numbers are multiple of 2. If you give 3, are the numbers multiple of 3? Let's check. So that becomes 3, 3 plus 2 is 5, 3 plus 4 is 7. So they are not multiples of 3. Okay, and give 5. So this becomes 5, 5 plus 2 is 7, 5 plus 4 is 9. They are not multiples of 5. 7, 7 plus 2 is 9, 7 plus 4 is 11. So the numbers are not multiples of 7. Okay, so the only number here, any one of the numbers a plus 2, a plus 4 is a multiple of 2. Okay, so when you put 2 here, so this becomes 2, 4 and 6. Okay, so they are multiples of 2. And the last question is, if p is a prime number and p divides k square, then p divides k. Okay, so this is the important one. We have see this fact while reviewing the concepts. This is k. Okay, the answer is k. If p is a prime number, if p divides k square, then p obviously divides k. Okay, k is the option. The remaining options are wrong. Okay, yes. So I have explained 2 MCQs. I have explained 2 MCQs of chapter 1, real numbers. So let's stop today's lesson, and I will be teaching in the next lesson some 5 marks or 10 marks. Okay, so if possible I will do some more MCQs. Okay, so that will help you while revising the concepts. Yes students, thank you. We will see in the next lesson.